Okay, guys, I hope we're ready to learn some math. Let's remember that last class, what we talked about was how to find the slope of a curved line by taking a point somewhere on the curved line. We've got c comma f of c. And then taking another point. This is where our actual point is going to be. And then we're going to take another general point, x comma f of x. And I guess we should put x comma f of x here. And saying that if we let this point get closer and closer together, finding the slope between these two would allow us to find the exact slope of a curved line. So we take the limit as x goes to c of the general y value minus our specific y value over x minus c. And this, of course, goes to 0 over 0, which is an indeterminate form, but we can use our properties of limits to evaluate it. So that's what we did last class, and we're going to practice that in just a second. Today, let me just tell you where we're heading, is we're going to be moving into a more general equation where by the end of today, we want to be able to say that, like, if we have a curved, we want a formula for the slope at any point. And so we'll be able to take functions and create a formula for it. We'll be able to find a formula for the derivative at any point. And we'll eventually be able to use this to come up with like rules. And so we won't actually have to use limits anymore because we will use limits today. So we'll use limits to find formulas. But once we have those formulas, we can just use those rules and it'll make things go a lot faster. Okay, so let's make sure we're all on the same page. This first one, you're supposed to find f prime of 4, which means the slope of this quadratic when x is 4. And let's see how we did on that. If you didn't get it right, let's see. We're setting up this limit. I'm going to go through it pretty slowly here to make sure we all know what's going on. We're going to take, so what this is a quadratic that looks like this, and we want to find the slope here. Not what's the y value, what's the slope. And to do it, we're going to have this, we need this point. So this point is going to be 4, comma, we need to plug it in. So f of 4 is going to be 16, because 4 squared is 16. 3 times 4 is 12. So f of 4 is 4. So we've got this point 4, 4. And then we're going to say that this is our point, 4, 4. And we're going to take another point, x comma f of x. So x comma f of x. And we're going to find the slope between these 2 points. And so that slope is the second y value, f of x, y2 minus y1 over x2, which will be just x minus x1. And what we want to do is allow this point to come infinitely close to where we are, and we do that with a limit. So the limit as x goes towards 4. Notice that it'll always make the denominator 0, and it'll end up making the numerator 0 as well. So let's plug in what f of x is here. So this is x squared minus 3x. That's what f of x is equal to. So x squared minus 3x minus 4 over x minus 4. And if you were to plug in 4 here, we would get 0 over 0, which is an indeterminate form. And so we want to use one of our techniques here. And our technique is, of course, going to be factor and cancel. We can factor the top. This is x minus 4 times x plus 1. By the way, if you're getting 0 over 0 and 4 makes the denominator 0, you can tell there will be guaranteed to be an x minus 4 on top because the numerator is also 0. So that's a shortcut that makes factoring a little bit faster because you already know what one of the factors has to be. So x plus 1, so it's the limit as x goes to 4 of x plus 1. We can just do direct substitution there, which is 5. And so that tells us that the slope, f prime of 4, the slope of this quadratic when x is 4 is 5. It's the slope of the tangent line, okay? The second question, let's see how we're feeling about this. Here we want to find the equation of the line tangent to g of x, which is the square root function at x equals 5. And hopefully we're feeling okay about it, but if not, we'll go through it right now and make sure we're all on the same page. So let's start by saying that to find the equation of a tangent line, this one looks like this, by the way. To find the equation of a tangent line, we need to first find a point. And so when x is 5, we need a point, 5 comma g of 5. So g of 5 is going to be square root of 5 plus 4 is 9. The square root of 9 is 3. 3 minus 1 is 2. So g of 5 is 2. So we've got this point at 5, 2. That's going to be part of our, we need that for the tangent line. And we also need the slope. And the way we find the slope is by finding the derivative, finding the slope of the tangent line. So g prime, and we want the derivative at 5, will be g of x, y2 minus y1. It's the same formula. So g of x, which is this is what g of x is equal to, minus g of 5, which was 2, over x minus 5. Okay. X minus 5. Okay, cool. And we're going to do the limit as x goes towards 5. Okay, so we could simplify this here, but let me just confirm that this is going to 0 over 0. 5 plus 4 is 9. Square root of 9 is 3. 3 minus 1 minus 2 is 0. And 5 minus 5 is 0. So this is an indeterminate. I'm going to rewrite this as the limit as x goes to 5. I'm going to simplify up here. This is square root of x plus 4 minus 3 over x minus 5. And hopefully we can see here, this is one of our limit techniques. A different limit technique we'll do, which is multiplying by the conjugate. So the conjugate of this is square root of x plus 4 plus 3. And so we need to multiply by the same thing in the denominator, square root of x plus 4 plus 3. And when we multiply, we will get in the top, the square roots will cancel out. We get x plus 4, and we'll get minus 9. And the middle terms cancel out because we get minus 3 square root of x plus 3 square root of x. In the bottom, we don't actually multiply it out. We're just going to leave it in factored form. X minus 5 times square root of x plus 4 plus 3. Okay, and this simplifies to x minus 5 over x minus 5 times square root of x plus 4 plus 3. The x minus 5s will cancel out, and so we're doing the limit as x goes towards 5 of, we need a 1 in the numerator still, so it's 1 over the square root of, so 5 plus 4 is 9, square root of 9 is 3, so it's 1 over 3 plus 3, which is 1/6. So that is the answer. No, hold on, that's not the answer. That is the slope of the tangent line, but it asks for the equation of the tangent line. So we need the equation, which I'll write right here. It's y equals the slope times x minus x1 plus y1. Remember, we need the slope. This is a transformation form of the line y equals 1/6 x. It got shifted to the right by 5 and up by 2. That way it actually hits this point and has the right slope. And it should make sense to you that the slope of this square root function would be about 1/6. It's much more horizontal than it is vertical. So hopefully we feel okay about that. All right. By the way, much of this first page is just like making sure we're good on stuff from previous days and going a little bit deeper. So let's see how you do on this one. If the tangent line to y equals f of x at 4, 3 passes through the point 0, 2, find f of 4 and f prime of 4. So it's telling you information about the tangent line to f of x and then asking you about f of 4 and f prime of 4. So let's see how you did. Well, f of 4, if the tangent line to f of x at 4, 3, so we don't know what f of x looks like, but we know that the tangent line is tangent to it at 4, 3. So whatever's going on here, the tangent line has to be touching there. And since the tangent line passes through, is at 4, 3, the function value at 4, which is what f of 4 is asking for, the function value at 4 is 3. And it just told us that. The slope at 4, well, it's going to be the same as the slope of the tangent line. And the slope of the tangent line, well, we can find it because it also passes through the point 0, 2. So we know it passes through the point 0, 2, and so we can do y2 minus y1. So 2 minus 3 divided by x2 minus x1 0 minus 4. Negative 1 over negative 4 is positive 1/4. So f prime of 4 is 1/4. And we can tell that because f prime of 4 is asking us what's the rate of change of this curved line we don't even know about, but the rate of change is going to be whatever the slope of the tangent line is. That's another definition of the, I hope that wasn't off the screen the whole time. That's another definition of the derivative. So, okay, let's see how we do on this one. Use the table. This next one is actually an algebra 1-ish problem. Let's make sure we feel comfortable about this. What is the average rate of change between 10 seconds and 60 seconds? And we want to include units. So what's the average rate of change here between 10 seconds and 60 seconds? So here's 10 seconds, here's 60 seconds. The average rate of change is just how much did the y variable change by. By the way, y is always in the bottom of a table. And if you're doing it left and right, y is always on the right and x is on the left. If you're doing it horizontally, x is on top, y is on bottom. So y2 minus y1 over x2 minus x1. And so this is 30/50ths, which is 3/5. And it asks for units. So the way we can do units is it's the top divided by the bottom. And what were the units of the top? So 44 minus 14, this was being measured in feet per second. And so this is 3 feet per second divided by, these were being measured in seconds. And so this is 3 feet per second per second. And hopefully we recognize this from physics. I don't actually know how many of you have taken physics. Well, I don't love the way this light looks. It's making kind of a weird shadow. Let's see if that makes it a little better. Hopefully we remember from physics that the rate of change of velocity is acceleration. And so this is 3/5 feet per second squared. When we say feet per second, often that's written as feet per second squared. That's the standard way in physics to write it. And so these are the units we would use. So again, the units are coming from its feet per second divided by seconds, because it was y2 minus y1 divided by x2 minus x1. So we just divide the units. Let's see what's going on. Okay, now getting into like the beginnings of calculus. What is one approximation of v prime of 40? So we don't have a curve here. Instead, they just gave us some data, and we want to be able to find what is the slope of the tangent line, what's the instantaneous rate of change at t equals 40, when x is 40. So what is the rate of change here? Well, it's not 35. That's what the velocity is. We want to find the rate of change of the velocity. And there are 3 appropriate estimates here. One estimate we could do is by taking the nearest point to the right. And so we could take this point. This is like x1, y1. And maybe we can call this x2, y2, in which case we would get, so this is like x2, y2, in which case we could get y2 minus y1 divided by x2 minus x1, which is 5/10 or 0.5 or 1/2. Now, this is a rate of change. It's feet. The units would be feet per second squared again, because it's feet per second. That's how much this changed by, per second. And I just want to make sure we understand what's going on here. This is saying between 40 and 50, on average, during those 10 seconds, the velocity went up by 1/2 foot per second each second. So it went up by 1/2 foot, 1/2 foot, 1/2 foot per second, 1/2 foot per second, 1/2 foot per second, 1/2 foot per second for 10 seconds, which is going up by 5 feet per second over the course of 10 seconds. So if you add up 1/2 10 times, that would be 5. And that's what's going on there. So that's one correct estimate. Another correct estimate is, instead of using the point to the right, you could instead use the point to the left. So this is still our x1, y1, but we'd use x2, y2. We would use the point to the left instead. And if we're doing it in this red color, it's still, it doesn't matter which one we subtract, but y2 minus y1, I'll do the bigger one minus the smaller one. That way we have fewer negatives, divided by x2 minus x1. So this is 6/10, which is also 3/5 from before. 3/5 feet per second squared. And the last acceptable estimate on the AP exam is instead of using the point right here, you can use the 2 points surrounding it. So we could use this point and this point, and they would take that. So if we do that, it would be y2, 40 minus 29, divided by 50 minus 30. And so this would be 11/20 feet per second squared. Now this is an interpretation question. This comes up, it's usually one question on the AP exam. Describe what this means. And so v prime of 40 means that the velocity is, it's how much the velocity is changing by. It's the rate of change of the velocity. And so in writing this sentence, we need to be very specific about what we write. The velocity at t equals 40 seconds is increasing by, and it doesn't matter which one of these numbers you use. I'm just going to use 11/20 because it's the last one I got, but it doesn't matter. 11/20 feet per second squared. So notice there are a few parts here. We need to describe what it is. This v is the velocity. This 40, we need to say what it is. It's the time. It means when the time is 40, and we need the units that go with the 40. So the velocity at time equals 40 seconds, this is required, is increasing. If you put is changing by, you would actually also get credit. The reason I said increasing is because these are positive. It means the velocity was increasing, but if you had put changing by, you would get full credit on the AP exam as well. By, and then we need to say what v prime of 40 was. Well, v prime of 40 was 11/20 feet per second squared. This unit is required, this unit is required, this value is required, this value is required, and what the thing is required. So there are 5 parts to this that you have to say, and if you're missing any one of them, you actually don't get credit. I will tell you, as somebody who's graded the AP exam numerous times, these are often missed, these points, because somebody will like miss one part of it. But with practice, you get it right every time. Okay, so we'll be practicing that later. In fact, now is a great time to practice. Go ahead and find one possible average rate of change, or sorry, one possible estimate for v prime of 70. So go ahead and find an estimate for v prime of 70. And after you've found what v prime of 70 is, we're going to talk about what it means, but let's at least do v prime of 70 real quick. So there were 3 possible answers. So here's 70, and we need to find the slope. It's asking for the slope at 70. And so this answer will not be exactly the slope at 70. It'll be an estimate by choosing as close a point as we can. So we're just trying to choose as close a point as we can. And so we could do y2. We could use the point to the right. So y2 minus y1 over x2 minus x1. And we would get 2 tenths, or 1/5. And this is feet per second squared. Or another possible answer would be, we could use the point to the left, and if we do that, we would do y2 minus y1 over x2 minus x1, which is also 10, so 3/10 feet per second squared. Or you could use the 2 points surrounding it, 70, so it's 60 and 80, and do 49 minus 44, which is 5, over 80 minus 60, which is 20, which is 1/4 foot per second squared. These are all fine. And then what does v prime of 70, what does one of these answers mean? Well, hopefully we got that it is it's an approximation of how fast the velocity is changing by. So v prime of 70 is the rate the velocity is changing at t equals 70 seconds. This is required. The rate was whatever this answer, I'm going to use whatever, my 3/10 was 3/10 feet per second squared. And these units are also necessary. Okay, so hopefully you're feeling okay about that. We'll get more practice on that over the course of this year. I don't actually know how many of you guys have taken physics and how comfortable you are with these concepts. If you've taken a physics class, you feel pretty good about velocity and acceleration and stuff. And if you haven't, you might, it might take a little while to get used to it, and we'll work on that. So you guys let me know. Okay, so last class, we learned how to find the derivative at a point. Now we're getting into our major concept for the day. And the concept for today is instead of having a point, we want to find a formula for what the slope is at every point. And so this time, instead of starting with c f of c, so instead of starting with a point that's like 2, 7, today we're going to say, well, we want the formula for the slope at any point. So we're going to start with the point x comma f of x. That's going to be our x1, y1. And we're going to pick a new point. And we're not going to call it like another letter. Instead, what we're going to say is in this model, we're going to say, look, wherever we are, we can just move over by a little bit. And oftentimes we'll use the letter h. We'll say, look, we'll just move over by h here. And the new x value then would, of course, be x plus h, whatever this x value was, plus h more, okay? And so what is the new y value then? If you're at x plus h, the y value is going to be f of x plus h. So f of x plus h, which just means put in x plus h into whatever the formula is, okay? So what is the slope between these 2 points? What's the slope of this secant line? Hopefully we got that it is y2 minus y1, so f of x plus h minus f of x over x2 minus x1, x plus h minus x, and this simplifies to f of x plus h minus f of x over, here we can do x minus x, which is 0. So we just get over h. Notice that we could not subtract these x's because they come inside of a function. You're not allowed to do stuff like, you can't do something like sine of x plus 2 minus sine of 2 and be like, this is the same as, this is very bad, don't ever do this. Sine of x minus sine of 0. You can't do that. So you can't get rid of things inside of a function. That's very bad. So don't try to do that, please. Okay, so we're saying that if we have an arbitrary point, we can make another arbitrary point a little bit h away from it and find the slope between those 2 points, y2 minus y1 over x2 minus x1. And this is going to be great because we can find the exact slope of this tangent line by doing what limit? This is a little tricky to see for kids at sometimes. The limit that we actually want here is we want this distance between them to get smaller and smaller and smaller. We want there to be less and less space. Oh my gosh, I hope this was not off. It was off camera. Guys, we were able to simplify this x minus x to not being there, but we couldn't simplify the x minus x in the top. So this is how it ends up. We want the distance between these two to be getting smaller and smaller. We want these points to get closer and closer together. And the limit that we could do to make that happen is the limit as h goes to 0. So as this distance between them goes away, the points will become more and more on top of each other. And this is the second major formula for calculating slopes using limits in calculus. And this is the more important one. This is the one that we'll use to come up with rules and never have to do limits again. Guys, we're going to put in some work over these next few classes. And then I promise you, like, everything from the first homework becomes trivial. You could do the whole first homework in like 5 minutes. Everything from like these homeworks takes like 3 minutes per homework. You're going to really love it once we, come up with these formulas, but it's going to take a little bit of work to get there. And we're going to see that today. So let's compare these two ideas. So the two forms of the definition is, this is a big deal. Let me get a pen and circle this. So our two forms are the derivative at a point, so a point like 2 comma 3, or more generally c comma f of c. Okay, and that formula was what is this is one you should know from the other day. It's the limit as x goes towards c of f of x minus f of c over x minus c. You do want to have this memorized, that this is the derivative at a point. This is important. And the other definition is the general derivative formula. So the derivative, we call this f prime of c. Hold on. I should have said f prime of c equals the derivative at a point. The derivative formula it gives you a formula for the derivative at any point. It's a formula for put in any x. So this one's only the derivative at a certain point. This one's the derivative at all points, and it'll just be a formula that tells you it. And that's the one we just came up with on the other page. It's the limit, this time as h goes to 0, of f of x plus h minus f of x over h. These both need to be memorized, and you want to be feeling comfortable about how to use them and what's the difference between them. This is kind of important. Okay, so let's look at how we use them, the two differences. Okay, we're going to find f prime of 2 given that f of x equals x squared plus 2x. Is this asking us for a derivative formula, or is it asking it for a derivative at just a single point? Well, it's just asking for the slope when x is 2. And so this is this one up here. This is the f prime of c1. And so the first thing we need is what is the actual point? So this is 2, and what is f of 2? So this is 2 comma f of 2, and we just plug in 2 here. 2 squared is 4, 2 times 2 is 4, so the point is 2, 8. So we're saying, like, what is the slope at 2, 8? Okay, and so the formula says we're going to do the limit as x goes towards 2 of f of x minus f of 2 over x minus 2. And to check and see if you've done it right, you can always see if this is an indeterminate form when you plug in 2, and it is. So what method are we going to go ahead and evaluate this limit? This is the limit as x goes to 2 of this factors into x plus 4 times x minus 2. I knew there had to be an x minus 2 there because there was an x minus 2 on the bottom. And now I can just do direct substitution. So this is 6. So this tells us that the slope at x equals 2 is 6. Okay, so slope is 6 when x is 2. The point is 8. So there's some point at 2, 8, but the slope is 6. So up by 6 over by 1. Okay, but what we're going to use more often is what is the slope formula for any point on this curve. And this is much more powerful. I think you're going to like this much better, although the actual calculation isn't nice. So let's find it. So here, this is asking us for a formula. So we're going to want to do this one. So the derivative formula, f prime of x, the slope of the curve at any point, is given by, we let the distance between those 2 points become 0. H is the distance between those 2 points, of f of x plus h. Now I'm going to do this. This gives some kids a hard time at first. So f of x plus h is when you plug x plus h in for both of the x's. So this is x plus h squared plus 2x plus h. This is all f of x plus h. I'm going to write it in red real quick. This is f of x plus h, because what I did was I plugged in x plus h into both the x's, minus, and we need to be careful here, minus f of x. Now, because f of x often has more than one term, we need to be very careful that we subtract the whole thing. This has to go in parentheses. I sometimes see people just put minus x squared and then they get the whole thing wrong. It doesn't work. You're subtracting all of f of x. And so here's what f of x is. So f of x plus h, we plugged in x plus h, minus f of x over h. And some cool stuff is going to happen here. So x plus h squared, hopefully we know are squaring a binomial trick. So this is going to be, when you have x plus h squared, we square the first one. We multiply these two together and then double it. So times 2. I probably should put that 2 in the front, but I already committed. And then we square the last one. Okay, so that's how we square a binomial. And then we can distribute here. So this is 2x plus 2h. This minus will distribute over h. And now the fun part begins. This will always happen. Everything that doesn't have an h in it, notice that x squared doesn't have an h in it, will cancel out. So the x squared will cancel out with the minus x squared. This one has an h in it, will not cancel out. This one has an h in it, will not cancel out. But the 2x will cancel out with the minus 2x because it doesn't have an h in it. And we'll be left with only terms that have h's in them. And what we can do with that is we can, if every term has an h in it, what are we allowed to do here? we can factor out the h. They all have an h, so it's h times, well, what's left over here? X times h times 2, we factor out the h, it's just x times 2, which is 2x. We factor out an h here, so we need a h times h is h squared. And we factor out the h here, and all that is left is 2, because 2h times 2 is 2h over h. And the reason all the things that don't have an h cancel out is because we need to be able to do this, because now the h's will cancel out, because we're multiplying and dividing by h. And remember, we are doing the limit as h goes to 0, and now that those h's canceled out, it's the limit as h goes to 0 of 2x plus h plus 2. So this h is going to go to 0, and what we're left with is 2x plus 2. And remember, this is the formula for what is the slope at any x value, 2x plus 2. We can try it over here. Earlier it asked, what is the slope at x equals 2? Well, this will give us a formula. The slope at x equals 2, we just put in 2 for x here. 2 times 2 is 4, plus 2 is 6, which is what we got before. But the cool thing about this formula is once you have a formula, I could also do like f prime of 0. Well, f prime of 0 is 2 times 0 plus 2, which is 2. F prime of 7 is 2 times 7, which is 14, plus 2, which is 16. And I can find the slopes at every single x value. I don't have to do a new limit for each slope. I just do a single limit. It gives me a formula, and now I can find the slope at every single point, which is really powerful, and it's going to allow us to come up with rules. Guys, I'm going to tell you, in like a month, you're going to look at this and you're just going to be like, oh, it's 2x plus 2. There's just like an easy rule that lets you do it, and you'll be able to do it in under 5 seconds, okay? And you'll get it right every time. Like 0 people will get this wrong. But for now, we're gonna see how this limit stuff works so that we can come up with these rules. All right, so let's see how you guys do on this on your own. Let's see how our Algebra 1 skill goes, how our determining a limit at a point goes, how our tangent line stuff goes. And by the way, this is, oh, you guys can't see this yet. This is another way of writing f prime of x. So f prime of x, dy dx, and y prime are the 3 ways we write derivatives. And if you're interested in why, I can tell you why, but I'm not going to get into it right now. It's historical rather than mathematical in nature. So this is a formula for the derivative at any point. So let's see how you guys do on your Algebra 1 thing. Find the average rate of change on the domain 1 to 5. So this is some parabola, okay? Let's see, it has intercept at 0 and -1, looks like this. Okay, so what is the average rate of change between 1 and 5? So that's an Algebra 1 skill. How much did it change on average by? So here we need 2 points. We need the point at the beginning. These are x values, so this is x1 and x2. So we want to know how much on average did this function change by. And so we're going to do, that's slope, just slope between 2 points. And so our x1, y1, our first point is when x is 1, and our first y will be 1 squared plus 1 is 2. So notice when x is 1, y is 2. And then when x is 5, y is 30. And so the average rate of change of this function on the domain of 1 to 5, so between x is 1 and x is 5, is, well, it went up by y2 minus y1 over x2 minus x1, which is 28 over 4, which is 7. So on average, between x is 1 and x is 5, we went up by 7. We know what? 7, 7, 7, 7, and when you go up by 7 4 times, you went up by 28, and so on average, it went up by 28. I shouldn't have chosen f prime of 3. I wish I had not chosen this number. This is unfortunate. Well, you guys don't know why, but I know why. Okay, so what about the derivative at the single point x equals 3? So this is, which one is this, first of all? Which one of these is this? Well, it's the derivative at a point. So we can just do the limit as x goes to 3. And by the way, if you find that you can't write this on your own, you might want to spend some time memorizing these, just like use flashcards. This might be a good thing to make flashcards out of, and just like flashcard it for yourself until you feel like you can do that. So the limit as x goes to 3 of f of x, which is x squared plus x, minus f of 3, so I guess I need to plug in a point. 3 comma 3 squared is 9, 9 plus 3 is 12. So f of x minus f of 3 divided by x minus 3. And this is going to be a factor and cancel 1. So this is x minus 3. I know it has to be because it has to be the same as the bottom, times x plus 4 over x minus 3. Factor and cancel, and we can plug in 3. And we get 7. Now, nowhere have I actually labeled this, and I really noticed on our last test our labeling wasn't great. Let's make sure we're doing this here. This is f prime of 3 is equal to 7. The slope of f of x when x is 3 is 7. It says a lot of information, and if you just write 7, I don't love this. Now, if you wrote f prime of 3 equals at the very beginning, then I'm more okay with it, but somewhere along the line, you need to say you're answering the question. So, so this is why I didn't like that I chose 3. If I had chosen 4 or 2, it wouldn't have been the average rate, but for quadratics, it turns out that the average rate of change is the same as the rate of change at the midpoint. It's only true for quadratics. It's not true for most functions, but for quadratics, it's true. Okay, what is the tangent line to the graph at x equals 2? What are the two things you need to find the equation of the tangent line? You should need the slope when x equals 2. So we need f prime of 2. And we need the point. So we need 2 comma whatever the y value is there. So 2 squared is 4. 4 plus 2 is 6. That's our point. And we just are looking for the slope at a single point. And so the slope at 2 is going to be the limit as x goes towards 2 of f of x minus f of 2, which was 6. So y2 minus y1 over x2 minus x1. And again, this is going to be a factor and cancel guy. So x minus 2 times it's got to be x plus 3 over x minus 2. And we will do the limit as x goes towards 2. And so we get f prime of 2 equals 2 plus 3 is 5. Oh wait, that's not the answer. What did it actually ask for? By the way, I have this skill and I've noticed some kids need to develop it. I sometimes box something, but I always at the very end go back and actually read the question. After you get your answer, make sure you're answering the right question. It happens to me all the time that I'm like, oh, I'm done. And then I go back and read the answer. I'm like, ooh, I didn't actually answer it yet. So we need the equation of the tangent line. So if we know the slope is 5 and the point is 2, 6, that is y equals 5 times x minus 2 plus 6. So this is the slope times x minus x1 plus y1. That's the equation of a line when you have a point and a slope. Okay, now what about the general formula? You can write f prime of x or dy dx, it doesn't matter. This means a little change in y divided by a little change in x. And so what it's talking about is like, okay, you've got some point x, and what happens if you make a very little change in the y value divided by the little change in the x value? That's like, the d is talking about, it's called a differential, and it means if you take a very, very small step. It has an implicit limit built in there. So, okay, so what is the formula? Well, this is our general formula, right? Where we want the slope at slope formula, okay? So this will be the limit as h goes to 0 of we always start with f of x plus h. So that means x plus h gets plugged into both these x's. So it's x plus h squared plus x plus h minus, we need to be careful here to make sure we put the whole f of x. So this is f of x plus h minus f of x. And f of x is x squared plus x. Make sure you don't forget this parentheses here. Divided by h. And what's our squaring a binomial trick? Well, it's you square the first one, you multiply these two together, and then multiply that by 2. So 2xh, and then we square the last one. Plus xh, plus x plus h, minus x squared, minus x, and here is the fun part. Everything that doesn't have an h should have something matching with it, so x squared doesn't have an h. There's the minus x squared. 2xh has an h. H squared has an h, but the plus x does not have an h, and it will cancel out with minus x. And then notice that everything left over has an h. And so our next step will be to factor out in h and just factor and cancel with fancy variables. Oh, my phone battery is getting low, guys. Let's see if we make it through this video. 2x plus, there's still an h left over here, plus 1. So h times 2x is 2xh, h times h is h squared, and h times 1 is h, all divided by h. And the h's will cancel, and so now we can say f prime of x, or dy dx, doesn't matter how you write it, is equal to the limit as h goes to 0 of 2x plus h plus 1, and that last h will go to 0, and it'll give us a formula with just x's in it. So the formula is 2 times x plus 1. And I want to point out, we ended up doing 2 different slopes here. We found f prime of 3, which we could find by just plugging in 2 times 3 plus 1, 7. That's the answer we got up there. But we could also do it for this one. F prime of 2 is, the formula is 2 times x plus 1. So f prime of at x equals 2 is 2 times 2 plus 1, which is 5, which is the answer we got here. So this is the more powerful formula because it means you only have to do a single limit, and it'll allow us to make our rules. Okay, guys, so let's see how you guys do on your own. Find the average rate of change over the domain from 1 to 5 for this function. So these are 2 x values. That's what a domain is. And so we need the y value that goes with them. So when x is 1, 1 minus 1 is 0. Square root of 0 is 0. 0 plus 3 is 3. And we need our second point. And that's going to be when x is 5. So 5 comma 5 minus 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. And hold on, something seems wrong here. 5 minus 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. Oh yeah, no, it's okay. Okay, so here are my 2 points. So basically this is saying like, okay, well, here's what the graph looks like. And it's saying between 1 and 5, what was the average rate of change? And so we just look at the beginning point and the end point, and we can do y2 minus y1 over x2 minus x1. So 5 minus 3 divided by 5 minus 1 is 2/4, which is 1/2. So the average rate of change is 1/2, which makes sense for a square root function. Okay, f prime of 3. Well, this is our at a point one, and so f prime of 3 is going to be the limit as x goes towards 3 of f of x minus f of c. So we need to find what f of 3 is. So f of 3, oh my gosh, I chose a terrible problem here. I'm probably going to redo this part of the video. Oh my gosh, this is so bad. Oh no. Oh, why did I choose 3? I don't want to redo this part of the video. Let's change this problem, guys, and I'll just, okay. We're going to change this problem to, instead of f prime of 3 here, I want to do f prime of 2. And that'll actually make things faster for our next part anyway. So f prime of 2 is going to be the limit as x goes to 2 of square root of x minus 1 plus 3 minus, we need to find f of 2. And f of 2 is going to be 2 minus 1 is 1, square root of 1 is 1, 1 plus 3 is 4. So minus 4 over x minus 2. And I promise this will work out better, guys. It would have been so ugly the other way I did it. I'm so sorry. I should have, I gotta change this. Okay. So, well, let's simplify a little bit. And we should recognize that this one will need to multiply by the conjugate. We have to multiply by the same thing on both the top and the bottom. And in the top, this will cancel out. We'll get x minus 1 minus 1 divided by, we always leave the one that only has one square root and it factored. X, we don't want to multiply this out. That would be so ugly. And x minus 1 is x minus 2. And we can see that the numerator then will cancel out with the denominator, and we will get the limit as x goes to 2 of the numerator is just 1 now over, what is this, square root of x minus 1 plus 1. And we can plug in 2. 2 minus 1 is 1, square root of 1 is 1, 1 plus 1 is 2, so 1/2. So 1/2 is our answer for f prime of 2, and I apologize there, guys. And now find the equation to the tangent line at x equals 2. Well, luckily we've already done this work here. At x equals 2, the point is 2, 4. So there's this point at 2, 4. And the slope of the tangent line, well, we already calculated that too. F prime of 2, we said was 1/2. So the equation of the tangent line is y equals the slope, which is what this tells us, times x minus 2 plus 4. There's our equation of the tangent line. Okay, what about our overall limit? So f prime of x, or dy dx, is going to equal, let's see how we do here, guys. It's square root, okay, so it's the limit as h goes to 0 of f of x plus h. F of x plus h means you just put in x plus h where it says. So f of x plus h plus 3 minus, we need to put f of x here in parentheses, and f of x is the square root, so square root of x minus 1 plus 3 over h. And okay, let's do some simplification. This is going to be minus this and minus this one, and these minuses will go away. And we will not be able to do factor out an h here like we could with polynomials, but we can do a limit technique that we should be starting to get comfortable with, which is multiplying by the conjugate. So square root of x plus h minus 1 plus square root of x minus 1. That is the conjugate here. I left this one alone and change this one to a plus. We have to multiply by the same thing on the top and the bottom. And in the top, we've got a square root times a square root. That will cancel out and get x plus h minus 1. Minus, these square roots will cancel out and give us, this minus will distribute. We need to be a little bit careful here. It's going to be minus the x, minus the negative 1 is plus 1, over, and we're going to leave the denominator factored. So h times square root of x plus h plus 1 plus, oh, hold on. This was a minus 1 here. This was a minus 1, so this should also be a minus 1. I'm sorry, guys, that is a minus 1 plus square root of x minus 1. And just like before, this is the fun part where things start to cancel. X minus x is 0. Negative 1 plus 1 is 0. And all that's left over on the top is an h. So h divided by h will cancel out and give us 1 over this guy. Okay? And we're doing the limit as h goes to 0. And when we plug in 0 in for h, we're going to get, so I'll write this here, x plus h minus 1 plus square root of x minus 1. The only h is right here, and it's going to go to 0 because it says the limit as h goes to 0. And so this h goes to 0, and we get 1 over the square root of x minus 1 plus the square root of x minus 1. And these are like terms. A square root of x minus 1 plus another square root of x minus 1 is 2 square root of x minus 1. And this is the slope formula. My goodness. Notice that we can plug in directly to get f prime of 2. F prime of 2, we would just put in 2 for this. 2 minus 1 is 1. Square root of 1 is 1. 2 times 1 is 2. And we get 1/2, which is what we got as our answer in this one. Now, notice this was more work. So if you only have to find the limit at a single point, this is a little bit faster and easier. But usually we're actually going to be doing limits of whole things. All right, guys, we have 2 special limits. And this is running a little bit long, so I apologize that this lesson is a little bit long. I also hope we got time to go over our test today. We want to find the general formula for sine of x. This means, okay, so here's sine of x, whatever. And we want to find a general formula for what the slope is at any point, okay? And this is actually on your first homework but you have to do it by like plugging in a bunch of numbers into a calculator and guessing. So we're gonna do a little math and then we're gonna memorize this one. So f prime of x is going to be equal to the limit. We want a formula, so which limit are we gonna do? It's the h one. The one is h goes to 0. So the one with h is the general formula one. The one with c is the one at a point. So the general formula one, we want the h, and it's going to be f of x plus h. So f of x plus h is sine of x plus h. We're just plugging in x plus h in for x minus sine of x over h. And guys, please do not cancel out these x's or try to subtract in some way. They're inside of a sine function. You cannot do that. Instead, what you can do is you can use your properties that you're supposed to know from pre-calculus. And we should know that this is, so sine of a plus b, I believe, I hope I don't get this wrong, this would be so embarrassing. So sine of a plus b, can I tell you how I actually memorize it? I know that sine of 2x is 2 sine x cosine of x, and so I'm like, okay, well, that's if they're the same. What if they're different? And so I'm like, oh, it must be sine of a cosine of b. I'm just kind of following this rule, plus another one that would end up being the same, so it must be sine of b cosine of a. So this is the formula we should know from pre-calculus, and we can apply that here because we have sine of x plus h. So it's going to be sine of x cosine of h plus sine of h cosine of x. This is all sine of x plus h. That's the property you should know from pre-calculus, minus sine of x over h. Now we're going to do something cool. We're going to use our limit properties. And what we're going to do is we are going to split up this into two limits. And what I want you to notice is that this one and this one both have a sine of x, but this one doesn't. This has a sine of h. So these have a common factor, but this one doesn't. And so I'm going to use my limit properties, and this may not have been apparent to you. And, you know, until you get like a feel for these things, you probably wouldn't see something like this, but this is sine of x cosine of h minus sine of x over h plus the limit as h goes to 0 of sine of h cosine of x over h. And notice that if we added these two together, it would give us back what we had up here. This one would just go in the middle right in there. We could add them because they have a common denominator. Now let's use some math here. What can we do here with this common sine of x? We can't subtract them because these are being multiplied, but we can factor out a sine of x. So I wish I'd given myself some more room here, but I did not. I'll try to squeeze it in right here. So this is limit as h goes to 0 of, if they both have a sine of x, I'm going to factor out the sine of x and multiply by cosine of h minus 1. Sine of x times cosine of h is sine of x cosine of h. Sine of x times negative 1. Oh, you guys can't see that. Sine of x times negative 1 is negative sine of x, so I've factored out the sine of x here, divided by h. Plus, here, I'm going to split this into two different limits. This is the limit as h goes to 0 of sine of h times sine of h over h times cosine of h. And I could split this up into two limits, but I'm actually running low on room here, and I apologize, guys. So hopefully you remember our limit properties. This is as h goes to 0. We can split it up into sine of x times, okay, hold on. Let's just notice that we could split it up into two different limits. The limit is, this one is multiplying times this one. And the nice thing is that this is one of our special limits. What is this limit equal to? 0. This is one of our special limits. So we get sine of x times 0, which is 0. Plus, here, we can split it up into this limit times this limit. And you'll notice that this is also one of our special limits. As h goes to 0, sine of h over h is 1. So we get 1 times the limit as h goes to 0 of cosine of, this should have been cosine of x, I believe. Yep, here it is. Sorry, guys. Sine of x, hold on. Yeah, sorry, this was a cosine of x, and I wrote it down as a cosine of h here, but that's incorrect. So as h goes to 0, this one goes to 1, and h goes to 0, there's no h's here, so this is just cosine of x. And so we get the formula is the derivative of sine of x is cosine of x. So if f of x is equal to sine of x, then f prime of x is equal to cosine of x. And guys, I do not expect you necessarily to be able to do this. This could be like a bonus problem on a test or a homework, but it would never be one that I expected everybody to be able to do. This is some really high-level math. But what I do expect is that you just memorize that if a function is sine of x, then the derivative is cosine of x, because that's pretty easy to memorize. Quickly, guys, we're going to try to do the same thing with cosine of x, and I'll try to get this done in the next 5 minutes. So if f of x equals cosine of x, determine f prime of x. So which one are we doing if we're looking for the general formula? That's the h one. It's the limit as h goes to 0 of f of x plus h. What is f of x plus h? Well, that's cosine of x plus h minus f of x, minus cosine of x over h. And just like before, we cannot simplify this in any way right now. You can't mess with what's inside of cosine, but we can use our properties. And hopefully we know from pre-calculus, or I hope I know, maybe I'm gonna get it wrong, I don't know, that this is cosine of x, cosine of h, minus sine of x, sine of h. This is, all of this is cosine of x plus h, minus cosine of x. And hopefully after seeing that last one, we can get a little bit of intuition about how we should split this up. What should we split this up into? And the right answer is, we notice that there's a cosine of x twice. And this one doesn't have a cosine of x. And so we're going to split it into two different limits. The first is going to be the limit of, I'm going to take these two. This is going to be like in group 1. And this one's going to be in group 2, because these ones both have a cosine of x and this one doesn't. And so we get in group 1, we've got cosine of x, cosine of h, minus cosine of x over h. And our limit properties say we can split this up into two different limits, plus this middle one in group 2, which is the limit as h goes to 0 of negative sine of x, sine of h. And what should we do next in this first one? What should we notice? What trick can we do? I hope that we notice we can factor out the cosine of x, because these both have a cosine of x. So we get the limit as h goes to 0 of cosine of x times cosine of h. Cosine of x, cosine of h is this. And cosine of x times -1 will give us negative cosine of x over h. And the other one, hopefully we can kind of see how we're going to group this. So this is limit as h goes to 0 of negative sine of x times sine of h over h. And notice that this is one of our special limits. It goes to 1. Notice that this is one of our special limits that we're supposed to have memorized. This goes to 0. So this one goes to 0. This one goes to 1. And so cosine of x times 0 is 0. And negative sine of x times 1 is negative sine of x. And so the derivative of cosine of x is negative sine of x. Okay, so the derivative of sine of x was cosine of x, and the derivative of cosine of x is negative sine of x. And we'll spend more time memorizing this later. But guys, that's it for today. Hopefully we're feeling not too overwhelmed. The big idea here is we have two different limit formulas. One is the derivative at a point. One is the overall derivative formula. The derivative at a point one is like f prime at a point, and it'll always be as x goes towards that point. The overall derivative formula will be as h goes to 0, because we used a different starting point. So hopefully you're feeling okay about this. You'll get a chance to practice it and hopefully feel better and better and better about this. I hope you have a good rest of your day.